Hello. In this video, we'll explore when a quadratic equation has real roots. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are constants, and a is not 0. The key to determining the nature of the roots lies in a value called the discriminant. The discriminant, often denoted by d, is calculated using the formula d equals b squared minus 4ac. A quadratic equation has real roots if and only if its discriminant is non-negative, meaning it is greater than or equal to 0. Let's look at the first case, when the discriminant is greater than 0. If d is greater than 0, the quadratic equation has two distinct real roots. Visually, this means the graph of the quadratic function, which is a parabola, intersects the x-axis at two different points. For example, consider the equation x squared minus 4x plus 3 equals 0. Here, at equals 1, b equals negative 4, and c equals 3. Let's calculate the discriminant. D equals negative 4 squared minus 4 times 1 times 3. This simplifies to 16 minus 12, which equals 4. Since d equals 4, which is greater than 0, this equation has two distinct real roots. Now for the second case, when the discriminant is exactly 0. If d equals 0, the quadratic equation has exactly one real root. This is sometimes called a repeated root or a double root. Graphically, the parabola touches the x-axis at exactly one point, which is the vertex of the parabola. Let's look at the equation x squared plus 2x plus 1 equals 0. In this equation, at equals 1, b equals 2, and c equals 1. Calculating the discriminant, d equals 2 squared minus 4 times 1 times 1. This simplifies to 4 minus 4, which is 0. Since d equals 0, this equation has exactly one real root. Finally, the third case, when the discriminant is less than 0. If d is less than 0, the quadratic equation has no real roots. The roots in this case are complex numbers, specifically a pair of complex conjugates. Graphically, the parabola does not intersect the x-axis at all. It lies entirely above or entirely below the x-axis. Consider the equation x squared plus x plus 1 equals 0. Here, at equals 1, b equals 1, and c equals 1. Calculating the discriminant, d equals 1 squared minus 4 times 1 times 1. This simplifies to 1 minus 4, which equals negative 3. Since d equals negative 3, which is less than 0, this equation has no real roots. To summarize, a quadratic equation, ax squared plus bx plus c equals 0 has real roots if and only if its discriminant, d equals b squared minus 4ac, is greater than or equal to 0. If d is positive, there are two distinct real roots. If d is 0, there is exactly one real root. If d is negative, there are no real roots. So, the condition for having real roots is simply b squared minus 4, ac is greater than or equal to 0.